Hi guys. So today I'm starting a new series on the concepts of language modeling, and it's gonna be we'll go from very basics, from like Bigram to the complicated language models which have come very recently, like Llama 3, and we'll go in the maths of it, then also to the code, and I'll guide you along with like the all the details of the code, and also you can code along with me. And like, let's have a discussion on Discord or in the comment section, and you let me know what you want to learn more. So let's see how it goes. Bye. Also, the code's going to be in pure NumPy, and wherever required, I'll use Jax and PyTorch. Thank you. Yeah. So let's start with the project. Um, okay. So let me first import the NumPy library as usual. Um, okay. Now, let's see what all we have here. Okay, so here, let's say this is the YouTube.1, the thing we're doing, and we have this names Indian.txt, right? This one. So this is a list of uh, the different Indian names, and like this is the code which will take it. So here we have to have Indian names, Indian kid names. So let's read it with open, read and split lines so that all the text will be split. So okay, Indian names. What's the we have names underscore Indian. Okay, so it's names underscore Indian. Is that capital? No. So this should work. Names underscore in the yeah. Yeah. So let's print out the words now. And yeah, so we have a long list of words here, all starting here A, but let's see the length of these words. Um, yeah, so we have like 55,691 Indian words, and we can like pluck out any one specific words from here. For example, if I want let's look at the 1200th word. It's an inch. Let's look at the 4,200th word is Balavadan. So what's the unique feature about Indian names is that they're mostly derived from Sanskrit. And in Sanskrit, if you see, the words are mostly uh, you know, created by joining two different small words. So that's like two or three, many different small words. And they have a root word, and different names are derived from it. So, so like if you see here, we have Amardeep, Amardev, Amarinder, and then we have Amarnath. So Amar is the root word. So yeah, so it would be interesting to kind of predict similar words, and let's create a model which will do that. So uh, so now let's see, you know, uh, so now length of for W in words, let's see what the length of words minimum length is. Um, that's two. That's very nice. So we have minimum of 2-letter word, and let's look at the maximum of it, and that's 25. So we even have words which are 25 letters long. Okay, so now we have all these words, right? And now we want to create a method in which we have to predict, let's say, the next character in the sequence, right? So let's come out of this for now, and let's think how we humans actually predict the next character in a very small example. So let's imagine alphabet, right? So we have alphabets from A B C D E F G H I J K L M N O P Q R S T U V W X Y Z. Now, this sequence, even if I give you, let's say, a C, for example, you know that next character is D. So there is some kind of information stored uh, which will look at C and then give you the D out. Your brain does that, right? So every character which you see has some kind of an information embedded, right? So there is some kind of embedding which represents that character. So now we exactly don't know how it works in our brain, but we can try to mimic it somehow. So let's say one way is to just do it like A, B, C, D, and just number it from 0 to 1 to 2 to 3, 4, like that, right? So okay, now we have these words, right? Now let's do this. So let's create an, this is called as a tokenizer in modern language, but let's create a very simple character level tokenizer here. So this is the tokenizer, and let me zoom a bit. Yeah. So here, um, let's first find out like, so we have these words, right? Um, so let's see first two words. Okay, words is not defined. I have to run it again. So yeah. So these are the first two words, right? So now if I have to, let's say join these two words to create a big string. So I can just do this and dot join method, and I can input the words in it. So now what it is doing is it's joining the two words, right? Let's if I keep this outside, now what it's doing is it's joining all the words separated by a space, this space, and then I'm just printing out the first two of them. I can print out even the first 10. Um, so why is it not printing? Wait. Yeah. So these are all the words, and I want to print out the first 10. Yeah. So these are the first 10 basically characters, right? Let's print the first 100 characters. Uh, so these are the first 100 characters, which has some amount of words in it, right? So if we put this inside, basically we'll get the first 100 words. Now what if I just remove this piece? Look, now this is basically all the characters in the words list we have joined, and I'm just printing the first 100 characters. Um, okay, so let's make a chars, which is this, and I just remove this. And now what I do is I want to do I want the unique characters, right? So we know that in alphabet it's A to Z, like, right? But we can have different characters like at the rate, etc. in our words. So like how Elon has named it XAI at the rate something something numbers also. So we can also have those names. So let's just do a different method. Now what I'll do is I'll just create a set of this. Now as you know, set allows only a unique entries. So if I do set of it, and if I then print the cars, I get a set of all the unique letters, unique characters. So you can see there is this dash also somehow, and there is this dot also, full stop. So these are also unique characters in the names we have, right? Now we have got the set. Let's create a list of them so that we have a list of characters. Okay. Now this is a list of unique characters. Okay. Now whenever we look at a letter, right? That as I told you, there is some kind of a embedding or a unique number which comes into our mind, right? So for that, let's create a uh, you know uh, so let's create a encoding where we do it encoder it's called. So we want from string to integer equals to. Now we want a dictionary where each character has a unique number assigned to it. So for that, I can do for, let's say, I comma character in enumerate, and I want cars. So this will give me the integer and the unique character in the cars. And now I can just do from cars to I for I in cars. And if I print this story, now see, for each special character, we have a unique number assigned to it, right? And capital and small are very different characters here. So the vocabulary right now is 54. If we had all small and from A to Z, we would have 26. But now we also have the space in some names and a dot in some names. So let's work with this for now. And this is fine. Let's now create from integer to string. So it's called as itos, let's say. And now what we want to do is we want to create a dictionary from, let's say, uh, uh, for, um, so from I to I, comma, C in, sorry, for C, comma, I. And now let's do the same, just use this story for now. We can do story and we can do dot items, which will give uh, the tuples of the items in it. Um, this will give the this, and then I can do just I to C. So this will create the itos for us. And if I print the itos, this is from, if you now see, this was okay. So story is from characters to integers, and itos is from integers to characters, and they always match because we have used story.items. Now let's say we want to encode this, right? So how will it look like? So let's say the very simple string, which is the hello world, which we all know, right? So this is the string we want to encode, and how will we do this? So for uh, character in uh, string, we will just do string to integer, uh, and just pass in the character here and just print it. And also we can just ints equals to a list, and we can just do ints dot append of that character, or that integer, sorry, unique integer. And here what we can do is just uh, print the ints list. So now see, hello world has been encoded in a list of unique integers. So H is somehow 3, capital H, E is 21, LL66, and 9 is the space character. So now we have this, and let's say if we don't have a character in our vocabulary, it will give us an error. Look, we don't have this exclamation mark in our vocab. So we can have as long a vocab we want, but let's work with this for now. Um, let's try my name. Yeah, let's do this. Yeah, my name is also encoded. So this was the encoding part of it, and let's say this is uh, the the integers we have. So we can do the same thing again for integer in string. I can just do inst dot append of. Uh, I can do itos of ints now, And sorry, I can just print this, and let's see what it gives. Yeah, this has to be square brackets. uh, Print extra bracket is here. I toss of I. Okay, so we don't have key error v. Let's do small v. Okay, we don't have a v somehow. It's this error. So let's try different word. Integer to string of a, key error a, I in string. Sorry. So I have to give this integers here. String is this, and now this will work. So we are getting this, and if this was Vivek, it will work, I guess. And if I give this here, this should give Vivek. Yeah. So this is the encoding and decoder part of it. And now, okay. So let's move ahead. So now we have all these names here, right? Um, Now I want to, yeah. So let's move ahead. Okay. So now we have all this. So let's go ahead and do for W in words. So we have this words, right? Let's print the first word. Incomplete input W in words. I want to print W. Aban. So this is the first word. We can print like 3 words also. Okay. And now what I want to do is print out the characters in it. So now what we're trying to do is what I said. So given a character, let's say D, I can predict E, right, which will come ahead of D. So I've learned somehow that after F, G will come. So I've learned this representation in my mind. So if I want to do that, I want the pairs of characters from all the words we have. So one way of doing it is for, let's say, so we have this word now, and let's create a list of it. So if I do chars as list of that word, I can just iterate through character 1 and character 2 in. So there's this cute way of doing it using zip, and I can do CHS, comma, CHS of uh, everything starting from 1. So what this does is it will create a tuple of characters, the outputs of characters and characters starting from 1. And what this will do is it will iterate through that zip, and it will return, let's say, so if I print out this CHS, it will be list of W, which is Aban, and CHS from 1 to everything will be A starting from here like this. And how when it will iterate, it should give AA, AB, BA. So if I just print it for only the first word, if I print ch1 comma ch2, I should get this. So this is working, and we can also increase it to trigram. So if this is the trigram, this will be the change. And what should it be? Pause the video and think of it. Yeah. So this will start from 2. And here also I'll have to print ch1, ch2, and ch3. So now you see we have AAB, ABA, and BN. So also now here we are missing some kind of a value here, some information here, which is that every word starts from a space, right? Every name and ends in a space. So the information that Aban ends at N and there is nothing in front of it has some significance. So now how to get that? So that significance is basically the word is starting from a space, blank character, right? And then it is ending at a blank character because it's a unique word. So that information also has to be put in. So one nice cute way of doing it is just adding a start sequence token and an end sequence token, right? So this, and now if we iterate to the cars, we see start AAA like this ban and with an end sequence token. So now let's for now let's work with bigram only. And if I want a bigram, I just need this much, okay, and I can do it for the first 2 words, okay. And now let's store it in, the store the counts of it. So uh, if I have a bigram, I can have a bigram uh, dictionary, bigram dictionary, empty bigram dictionary, and now what we do is let's create a tuple of it. So what I can do is bigram equals to, I want to get the bygr dot get. We'll get the yeah. So let's create a bigram equals to a tuple of ch1 comma ch2. So now we are creating tuple, and what we'll do is bigram retrieve the counts. So here I can pass in bigram and retrieve the counts and add 1 to it whenever we see the same thing again. So this will return the value. Let's say we don't have the value, it will return an error. So that's why let's add 0, which is the default value, and we want to assign this to bigram of uh, the bigram, and this should work. Yeah, let's not print it anymore. And now let's print the bigar. Okay, so for the first 2 words, we now have the 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 tuples of the bigrams, where whenever we see an a, what are the instances where we have small a in front of capital A. Similarly, after a, b came twice, after a, n came twice. So let's just do it for all the words, okay, and just print this. Now we have all the bigram tuples, okay. Now this is, we cannot understand a lot. So this is like 16,000 also we have. So how to sort this? So for sorting it, we can just pass a sorted on bigram dot items. So let's just first print bigram dot items. Now here bigram dot items returns a tuple of both the keys and values inside the big dictionary. So we have a tuple and a integer value. And now if I do sorted over this, which will just sort it, but now there's an error. Now this is sorting using the keys and also the first element from the keys. That's why space character all came before. Now sorted takes in an argument, which is the key argument. Now this is a function which tells us what we want to sort by. So now we can do lambda of x to x, and I want the second element, which is the integer of that. Now if you see, it has sorted the bigram.items with respect to the x of 1, which is the integers, the occurrence of them in the total data set. Now this is from start to small to big. So x of 1 will have the integer values. So negative of x of 1 will basically give us negative values of the counts, and sorting it will basically mean the highest negative value will come first. That's why sorting this, now we see that n followed by a occurred the maximum number of times, right? Sorry for that. The maximum number of times, and a being an end character came 16,716 times. So that is also a very high occurrence in our data set. Now, can you guys think of a way of using this whatever what we have got here, and creating some kind of a logic or a model which will predict what would come next given something, right? So ideally, if I give you that the character you are looking at is a, because you have seen n coming after a lot, the most probabilistic thing of n coming after a should be normal, right? So we want to somehow create a probability distribution uh, of what the character in front of a specific character is. So for that, what is the way? So we want to create a probability distribution using the counts we got. So for this, let's first have a way of storing it in a proper way. Now this is very you have to scroll all the way to get the counts, and this is very not nice. So first let's just present it nicely. Now so if you see the vocab, okay, vocab is the okay. So for now, let me just copy this, and I want to remove this for now. I'll just have a space. Let's have a space here, and list of w. Now space is also unique, and let me do print again, and let me just comment this out. I don't want this, and let's just print this for first three. Now let's look at the vocabulary. We created this toy, right? So length of toy is 55. So our vocabulary is 55, and this is, let's create a matrix where we have numpy dot zeros of vocab comma vocab. So just do this and vocab comma vocab. Hmm, yeah, sorry. This should be in a bracket. And if I print the end now you see end dot shape is 55 comma 55. Now this is all zeros for now. Now let's just, whenever this occurs, we want to add it to uh, the let's say we have the index of the character and index of the character. So what I mean is if we have a third index, which is the uh, integer to string, the decoder of that index is some letter, comes after another letter. So just we can move in that matrix and just pluck out the count of it. So what we can do here is we can just get the uh, integer string to integer of ch1, which is the ix1, and string to integer of ix this, and just print it for now, ix1 comma ix2, and just not print this. So now we have got the embeddings or the integers for those characters. Yeah, so here now we get this. Let me replace this with a dot for now. And I just want to print the character 1 and character 2. So this we are trying to build a matrix here. So firstly, we would require the indexes of that matrix is from string to integer of that character 1, and I just need to copy this, get the x2 and character 2, and now I would like to print the um, ix1 and ix2. Let's look at what the integers are respective. Yeah. So these are the respective integers. Now we can index a matrix which would be basically of size of vocab size by vocab size. So let's say my vocab size is the uh, length of itos or string. So let's print this. What is vocab underscore size? It's 29. So I just changed a bit here. I added some text and I added the this dot lower to decrease the vocabulary a bit because our data set is too small here and it's not looking very nice. So I just did that. Now we have 29 as vocab size, and a new story is something like this, which is all lowercase letters, right? All the words are now lowercase. So vocab size is my 29. Now let me just move this up. So I want to do this. I'll run this. And then I would like to create a matrix called n, which is numpy dot zeros of size 29, wait, 29 comma 29, and I want d type to be numpy dot int 32. So this should work. Yep. And if I see the n now, it is 29 by 29 of zeros. So now let me just show you the numpy dot shape, which is 29 by 29. Now what we can do is we can index that this n here what I can do is wherever my n is ix1 comma ix2, whenever this occurs, this tuple of two consecutive characters occurs, I just want to do plus equals 1. And I don't want to print this. I don't want to do it for first three. Now let's see what my n looks like. Now you can see there are some increments everywhere, right? This is because we have only used first three. If I just remove this now and run this, now my n should change. And now we have a very beautiful matrix. This is very similar to this one, but now it is in the form of a matrix. Now, each row of this matrix here represents a specific character because we have index ix1 comma ix2, right? So ix1 represents what came and ix2 represents what came next to it. So if we pluck out n of let's say 0, this will tell me the uh, the the first row, which is ix1, uh, what are the counts. So here n of 0 uh, is basically uh, the zeroth ix, which is h. So this uh, this n of 0 is basically representing the counts of all the characters which came after h. All cars which came, counts of all which came after h. Now, but now these are counts. So how do I get the probability using this? So before we move to probability, um, let me find a way to uh, plot this a little bit better. So I'll import this here. This is basically 29 by 29, fixed size of 24 using matplotlib, and we are just plotting this, which will make it look a bit beautiful. So it's plotting, yeah. So now you can see these are the counts, and you can look at the intensity of each. So this is H 42. This is H after C 31 times. So you can see all the pairs here. Let me zoom more. Yeah. So now again, let me work with the uh, H here. So these are the counts, right? Now, one way to find probability is just divide it with the sum. So prob is equal to capital N of, let's say, 0, and I want to divide it with sum of that row. So this is numpy dot sum. Sorry, I just want n of 0 dot sum. Let me just print this individually. 5,000, 50,471. What if I divide this and just print the prob? Now these are the probabilities, right? So if I see the probability here, this is e power minus 4. This is e power minus 2. This is 0 0.01. This one is 1.8 e power minus 1, just 0.1. 0.1 is 1% probability. Then this one is 0. Okay. This is 1%. Okay. Now, what if I do prob dot sum? This is again 1. So which means that probability is probably right. And this could be done for all of them. That's again 1. So one thing we can do is we can iterate through all the rows. So for I in range 29, I just want to do this, right? And n of I, and I can just, you know, and just print it prob.sum. So this will be number of ones. So which means we are getting probably very nicely. So this is one way. But now let's see how we can do it, using matrix, the power of NumPy, which will be very efficient. So what we can do is we can just, and we can create a copy of this so that this won't have any problems. So this is M. Now what we do is uh, we calculate the sum, which is m dot sum. And now because we have a 29 by 29 matrix, when we do sum, we have to provide the axis. So the default is 0, which is summing through the columns. So summing through columns is not what we require, right? But m dot sum, this will give me sum. These are column sums, and I want row sums. And now what I want to do is divide each row with the sum of that row. This can be done by, just m equals to m divided by, I want the sums. Let's try this. And I print m. Now we have divided with sums, and let me just see m of 0. And let me see the sum of this row. This is not 1. Can you think of this why? Why is this happening? The reason behind it is there's this thing called as broadcasting. Now, if you see, this is 29 by 29, and when I divide it by sums, so if you see, the shape of the sums is 29. It is only one axis. So when we are dividing the M matrix with the sums matrix, what is happening is this is 29. So NumPy is creating an separate axis wherever the axis is not present. And the rule for broadcasting both in PyTorch and NumPy is that it will shift all to the right and create an axis here, fake axis. And then it will carry out the division. And in the division, because 29 by 29, to divide it by 29, you have to know what to divide each element by. So it will make a copy. So just imagine 29 by 29 dividing by 29 as a row, because 1 comma 29 is a row with one column. And now that row is being divided like this. So it is copying through column. And because it's copying through column, the sum of the row is being copied to the column and divided, which makes no sense. So that's why this is not 1. So the way to solve this is to create a new axis thingy. So numpy dot new axis, or we could even reshape. So for all elements, and I want numpy dot new axis. And if I do this now, sums. axis 1, and I want to reshape this. Uh, this should work. Yeah, so this is numpy.new axis, and let me see. So what's the issue here? So now let's see the shape of this. So this is now 29 by 1. Now what we have done is it is 29 rows with one column. And now when we divide it, the sum, which is the first sum of the first row, is going to get copied like this. So let me do, uh, so sums equals to this again. So once I do this, uh, dot sum axis 1. Yeah. So I will just add this here and let me just see. Yeah. So I have this sums here. Let me delete this. And if I divide this by sums now, it should work. So this is summing to 1. Let us keep a precaution here. So if I so m of 2 is not 1 here because it is uh, I think adding over the sums again and again. So I need to reinitialize this. Now it is 1. Uh, so sums dot shape here is 29 by 1. So I can just add this. And now if let's add it to a new thing called prop, and let's look at this. So even for prop, I need to initialize this like this. So sums like this, yes. And if I add a cell and look at prop of 0, these are the probabilities, right? And dot sum works. Yes. So now we have the probability matrix. Now we have to generate. So let's start with generation. So keep this in mind. This is called as broadcasting, and this is very important to learn the rules of broadcasting. It is very like you won't like it, but it's very important. So now let's start with, so this is rules of broadcasting. Now let's start with generation. So this probability matrix is actually a trained model right now. It's very um, you know very basic, but this is the trained model. So for generation, let us uh, use NumPy. So now so there's this function if you might have used in NumPy, which is basically NumPy. What was the function? Yeah. So the if you Google it, it's called as numpy.random.choice. So if I have, let's say, a list of probabilities, so probs temp equals to list of probabilities like 0.2, comma 0.1, comma 0.6, and let me just see. This is yeah. So numpy random dot choice. So if you look at this here, if you see for so if these are the probabilities, and I want to get pluck out different numbers with some probabilities. This is the way. So so I have to give. Let me just so numpy dot random dot choice, and here I need to give first parameter is the length of the probabilities. So let me just create a cell here. So I need small prop equals to capital prop of 0, which is for h. The probability is for h. So these are the probabilities, and length of prop is used. And this also takes another argument, number of samples, which is basically, let's say we want 3, and we have to give p equals to probability. And let's see, the number of samples is not an argument. I guess it is size. So this is size. Yeah. So now we got 3 outputs, which is 666. So sixth element it likes a lot, I guess. What if I do 10? Yeah, now you see 5, 18, 24, but it basically likes the sixth integer a lot, this probability. Now for generation, let me do for I in range. Let's start with one generation first. Now we start with some element. Let's say we start with the new line character, and start. Let's call it start. And so here, what we can do is we need stoi of start. So this is the integer, and we need to pluck out the probability of this. So ix1 is this. Then I need to p equals to the probability of this. So prob matrix of ix1, and this probability, this has to be used here, and I need only one sample, and I can print this for now. So one element, um, yeah, so and I need the element, so 0. And let me just do numpy dot seed as, let's say, 1 2 3 4 5. Numpy has no seed. How to set the seed? It is, I think, random. So numpy dot random dot seed that 26. So if I run it multiple times, this will come out this thing. This is nice. And now let me create a word and so okay. So this is the start. Now this the new element which we have got. We need to find the string. Sorry, itos of this thing. So I can call this new, and this itos of new is my new string. Um, so if I print this, word is not defined. So word is an empty list. So J. And if I do here while true, and now if I run this, so I need to, yeah. So this will keep on generating. I need to stop. And where do we need to break this? So if the next character predicted, so if new equals to um, string to integer of this new line character, then I need to stop. Right, getting at this, right? Okay, the problem here now is we are not updating the new. So what needs to be done here is the new, after it's being used, firstly it needs to be appended. So word dot append, I want to append new, and if new is toy, I want to break. And also if it's not, I want to do start equals to new. So and then continue. So if I do this now, story of start, so story of start, story of start, story of start. Start is this. I need to do this here. And start is new. And then we go here, can probability, story of start. New is an, oh sorry. So this needs to be again story of that new. Oh sorry, itos, right? Yeah. New here is a probability, keep in mind. So this needs to be itos of new. So ja is the word it created. If I run again, it will still be ja. So let me create 3 words. So where these are breaking is wherever there's this new line character. So if I want to, um, print that new line character, so what I need to do is I need to not print this actually. but whenever we are breaking, we need to uh, this dot join of word, and I want to print this. So sequence string, for instance, if this breaks, uh, expected string intents. Okay, so I think we can just print it maybe after each breaking in the while loop. So here maybe this would work. Mm, what's the issue here? Mm, mm, mm. Let me just do this. So what if I print start here? Sure. And what if I print word here? Ah, so here also it should be, uh, yeah. So this is right. Okay, don't want this anymore. Yeah, so these are the words. So now we have generated 3 different words. So let me generate 10. So this is somehow Kanya, Dan, uh, Danthat. These are the words which our model is generating. And yeah, so if I just change the seed, these are the different words it's generating. So still it's not making sense, but yeah, so this is the first video. And hope you liked it. So uh, do like and share. And in the next video, uh, we'll try to, improve this. So yeah, bye.